Good morning, dear students. Welcome back again with a new session of Maths to 10th Standard Pythagoras Theorem. We already studied about Pythagoras Theorem, but a little introduction about Pythagoras Theorem we are going to study it now. The statement of Pythagoras Theorem. In a right angled triangle, the square of the hypotenuse is equal to the sum of the squares of the remaining two sides. In order to explain that, here one diagram is drawn here. Triangle RQP. Opposite to P I have given small letter P. Opposite to Q I have given small letter Q. Opposite to R I have given small letter R. Then condition for Pythagoras theorem, it should be a right angled triangle. So in a triangle PQR, angle PQR is 90 degree. Therefore it is right angled triangle. So for length of PR square equals to length of PQ square plus length of QR square. If I put its value, it can be written in the form as Q square equals to R square plus P square. In order to explain it with the help of some values, numbers, it will be more easy to understand. Here 41 square equals to 40 square plus 9 square. Therefore, these three numbers are also called as Pythagorean triplet. 41 square is 1681. 40 square is 1600 and 9 square is 81. So here LHS and RHS both are matching, and therefore these three numbers are called as Pythagorean triplet. Similarly, 5 square equals to 4 square plus 3 square. 5 square is 25, 4 square 16, 3 square 9. So LHS and RHS are matching, and therefore 5, 4, 3 is called as Pythagorean triplet. Similarly, 61 square equals to 60 square plus 11 square. 61 square 3721. 60 square 3611 square is 121, and therefore adding these two we get as 61 square, and therefore 61, 60 and 11 is called as a Pythagorean triplet. Likewise, many Pythagorean triplets we can find it out. One activity based sum is there in your textbook, with the help of which we can find out many Pythagorean triplet. Few more examples of Pythagorean triplet I have given here. Now, what is actually Pythagorean triplet? In a triplet of a natural number, if the square of the largest number is equal to sum of the squares of the remaining two numbers, then the triplet is called as Pythagorean triplet. Here the biggest number is 34 square, and the square of 34 will be equal to sum of the square of 16 and 30, and therefore 34, 16 and 30 is a Pythagorean triplet. Likewise, we can get another Pythagorean triplet 5, 12, 13, 24, 25, 7, etc. I expect that you too should make few of the Pythagorean triplet to ooze confidence in yourself. You can do it very easily. Now we'll move to another part of this lesson. Property of 30, 60, 90 degree triangle. We have already discussed in 9th standard, but again a little introduction about it, so that it will help us to solve few sums based on this. What is the statement of it? If acute angle of a right angle triangle are 30 degree and 60 degree, then the side opposite to 30 degree angle is half of the hypotenuse, and the side opposite to 60 degree angle is root 3 upon 2 times the hypotenuse. Now suppose your triangle is LMN, angle M 90 degree, L 30 degree, angle N 60 degree. And if I assume that let Ln will be 6 centimeter, with the help of this property we can find out the value of Lm and Mn. Let's see how. Side opposite to angle 30 degree equals to mn. This is 30 degree. Opposite to 30 is mn, equals to 1 upon 2 times the hypotenuse. Here it is written 30 degrees half of the hypotenuse. Acute angle of a right angle 30 degree and 60 degree, then side opposite to 30 degree angle is half of the hypotenuse. So therefore here half into ln is hypotenuse. If we'll put the value of hypotenuse, we'll get mn equals to 3 centimeter. Similarly, if we take side opposite to angle 60, the angle 60 opposite to 60 is lm. So we can find out the value of lm if we are knowing the value of ln by following the property side opposite to angle 60 degrees root 3 upon 2 times the hypotenuse. So root 3 upon 2 into hypotenuse is 6. Cancel it and we get lm equals to 3 root 3 centimeter. So we have solved or used the property of 30, 60, 90. Now we are going to use the property of 45, 45, 90. If the acute angle of a right angle triangle are 45 degree, 45 degree, then each of the perpendicular side is 1 upon root 2 times the hypotenuse. This is 45, 45. Then perpendicular sides, that is angle x. If I know the value of hypotenuse, I can find out the value of xz and xy by using this property. Side opposite to 45 is 1 upon root 2 times the hypotenuse. Suppose if I take the xzy as root 3 root 2. So the property is what? Side opposite to angle 45. This is zx opposite to zx angle 45. This is xy opposite to side xy is angle 45. So xy and xz both are opposite to angle 45 degree is 1 upon root 2 times the hypotenuse. Value of hypotenuse is 3 root 2. So putting the value of 3 root 2, root 2 gets cancelled and I get the value as zx equals to xy equals to 3 centimeter. So we have used the property of 30, 60, 90 and 45, 45, 90. Now theorem on similarity of right angled triangle. Statement: in a right angled triangle, if the altitude is drawn to the hypotenuse, then the two triangles formed are similar to the original triangle and to each other. Let's see how. This is a right angled triangle. Altitude is drawn to the hypotenuse. Given in triangle ABC, angle ABC is 90 degree, seg BD is perpendicular to seg AC and A-D-C implies that ADC are collinear. What have we to prove? We have to prove that smaller triangle ADB is similar to the bigger triangle, original triangle. Then smaller triangle BDC is similar to again the original triangle ABC. And also the remaining two smaller triangle, that is triangle ADB and triangle BDC, both are similar to each other. So all three triangles are similar to each other, that we have to prove it. This is called as theorem on similarity of right angled triangle. Let's see how. Consider triangle ADB and ABC, any of the smaller triangle and the bigger triangle. So here we have considered triangle ADB and triangle ABC. While writing the name, you have to be very much careful that name should be written in 1-to-1 correspondence. If it is not written in the form of 1-to-1 correspondence, then you may not get the appropriate answer. Now what does 1-to-1 correspondence implies here? If I take here angle A, here also see angle A, both are same. And angle D is 90 degree, here angle B is 90 degree. and then angle B and angle C. So here common angle is there and the remaining two angles are matching with the other two remaining angles. So we call it as one-to-one correspondence. So while naming, you have to be careful that the name is written in one-to-one correspondence. Now how to prove these two triangles similar? Angle DAB congruent to angle BAC. DAB and BAC. See, same angles are there, but name is different, and therefore we give the reason as common angle. Then angle ADB congruent to angle ABC. ADB 90 degree, ABC also 90 degree, each 90 degree. Therefore, both the triangles are similar by AA test of similarity. Now consider another smaller triangle and the bigger triangle. Triangle BDC and triangle ABC. BDC, ABC. Angle BCD congruent to angle ACB. Why? Reason, angle C is common to both the triangles. Then angle BDC and angle ABC. Angle BDC and angle ABC. Each angle is 90 degree. So here both the angles are congruent. Since any two pair of the two triangles are congruent, and therefore we can say that the triangles are similar by AA test. Now with the help of equation 1 and equation 2, equation 1 this and equation 2, we can see here that one pair or one triangle, name of the triangle is same here. Triangle ABC, triangle ABC. Therefore, I can say that triangle ADB is similar to triangle BDC. ADB similar to BDC from 1 and 2. Now, making use of equation 1, 2 and 3, I can say that triangle ADB is similar to triangle BDC similar to triangle ABC. And thus, I have proved that all the three triangles are similar to each other. This theorem is nothing but theorem on similarity of right angled triangle. Remaining theorem we will discuss in the next video. Till then, have a great day.